Good day, guys. For today's lesson, we are going to take up increasing and decreasing of the function. And here's what you need to know about increasing and decreasing of the function. The graph is increasing if it rises from left to right over an interval. And the graph is decreasing if it moves down from left to right. Here are some examples and steps in determining the interval where the graph is increasing and decreasing. Example number 1. The given is f of x is equal to x cubed plus 6x plus 9x. Find the open interval where the given function is increasing and decreasing and locate all the possible points where the tangent line is horizontal. As I have said, the given is f of x is equal to x cubed plus 6x plus 9x. To find out the open interval here are some steps. Step number 1, find the first derivative of the function, which is f prime of x is equal to 3x squared plus 12x plus 9. And step number 2, find the critical point of the first derivative. But in order to find the critical point, we need the first derivative to be equated to 0. So here it is, 3x squared plus 12x plus 9 is equal to 0. We're going to solve for x. So by simplification, we have 3 times the quantity of x squared plus 4x plus 3 is equal to 0. And by factorization, we have 3 times the quantity of x plus 3 times the quantity of x plus 1 is equal to 0. So we have x plus 3 is equal to 0, or x is equal to negative 3. That will be our negative 3 will be our critical point number 1. And x plus 1 is equal to 0, or x is equal to negative 1, and also that is a critical point. And negative 1 and negative 3 are the points where the tangent line is horizontal. Using this critical point, we can now plot the open interval where the graph is increasing or decreasing. So here is the open interval. From negative infinity up to negative 3, from negative 3 to negative 1, and from negative 1 to positive infinity. But in order to find out where of this interval does the graph is increasing or increasing, we need to pick a point within the interval and plug it in our first derivative. But here's what you need to know first. If f prime of x is greater than 0, the graph is increasing on that particular interval. And f prime of x is less than 0, the graph is decreasing on that particular interval. So to test if negative infinity up to negative 3, if the graph is increasing or decreasing, we are going to pick a point within the interval which is x is equal to negative 4 and plug it on our f prime, or our first derivative. So we have positive 9. That means the graph is increasing on that particular interval. So to test the interval negative 3 to negative 1, I have picked negative 2 as the pick point. We cannot pick the negative 3 and negative 1 because they are excluded from that interval. So negative 2 is the point we're going to test the derivative. So the result will be negative 3. So that means the graph is decreasing on that particular interval. And finally, from the interval of negative 1 up to positive infinity, I have picked my test point positive 2 this time. So by simplification, we have f prime of 2 is equal to 45. So meaning the graph is increasing on that particular interval. So as you can see from the picture, here's the original. Here, this is the graph of the original function. So from the interval negative infinity up to negative 3, as you can see, the interval is increasing. However, from the interval negative 3 to negative 1, the graph is decreasing. And finally, from negative 1 to positive infinity, the graph is going back, increasing again. So, that's all guys. Thank you.